The main idea behind this project was to create a simple memory game. To progress through the game, the user is required to observe the sequence in which different coloured LEDs blink, memorize the pattern, and then repeat it, using buttons corresponding to the given LED. The game lasts for several rounds, length can be configured, and with each passing round, the number of LED blinks increases by 1, starting with just 1 blink up until the user makes a mistake or successfully completes all of the rounds. Each time the program starts, a different pattern of blinks is generated and then repeated throughout the single game. During the game, different animations are being displayed, indicating whether the game was won, lost, or has just begun. At the beginning of the game, the user can also choose one of 3 difficulty levels, influencing the duration of LED blinks. The higher the difficulty level, the shorter the amount of time each LED flashes for. To help a player memorize the pattern, the user is also given audio cues in the form of simple sounds, each corresponding with 1 LED, lasting for as long as the LED flashes. During the game, different animations are being displayed, indicating whether the game was won, lost, or has just begun. The project consists of several components put together to form one working digital organism. The central, most important unit is the Arduino board, which is responsible for a number of functions, from processing the code, outputting the signal, and storing the data to the internal memory. All of the other components are connected to the Arduino board via a series of pins, either digital, 1 to 13, or analog, A0 to A5. To create the memory box, we've used several components. The first one, the keypad membrane, which was connected to the Arduino board through 7 digital pins, each controlling 1 row or column of buttons. Since our device utilizes only 8 buttons in total, the last row is disconnected, making room on the board for other components. We've also used 4 different colored LED lights: red, green, blue, and yellow. Too much current would cause the LED to burn out almost immediately. Therefore, implementing resistors, in this case 220 ohms, is required to limit or choke the amount of current flowing through it. Each LED has 2 leads, one of them being positive, the long one, and the other negative. The positive lead needs to be connected to the source of electricity, the digital pins, while the negative lead goes to the ground pin. The LEDs were connected to PWM pins, which allow us to create a dimming effect later on. The last major component used in the project is a buzzer. The buzzer used in our project is passive. We've used one 220 ohms resistor to slightly muffle the otherwise loud buzzer. All of the LEDs used in the project, the buzzer and the resistors, were soldered together with pieces of wire, making the connections permanent. Because of it, a breadboard was no longer needed in the project. The source code is divided into a few smaller sections. At the very beginning, we've included one additional library, enabling us to use various methods for controlling the keypad. Right below, we've defined numbers of pins used by LEDs, buzzers, and keypad. The next section of the code declares a few variables necessary for the program to work properly. The constant variables named C, D, E, and F assign one of the several integer numbers, each representing a different sound frequency used by the buzzer to play a different tune. Next, we declare the number of horizontal and vertical rows of the keypad. We also declare the names of each button in a form of 2-dimensional array of characters. Here, the rows of buttons are assigned to individual pins, establishing the all-important physical connection between the keyboard and the Arduino board. The very next line of code initializes an object of the class keypad, called custom keypad, which maps the keypad buttons. The next 2 lines of code are responsible for creating 2 arrays of integers, one for storing random sequence of numbers, which will impact the order of the LED blinks, and the other one for storing the answers inputted by the user by pressing the buttons on the keypad. The random seed method initializes a pseudo-random number generator, causing it to start at an arbitrary point in its random sequence. This sequence, while very long and random, is always the same. We use analog read A0 as method's parameter, seed value, to make sure that generated values are different each time the method is invoked. The method begin_game_animation causes the LEDs to blink in a predefined sequence specified in the method body. The next line of code takes the input from our user by pressing one of 3 keypad buttons responsible for choosing difficulty level, which is accomplished by waitForKey method for the object custom keypad, stores it in the level variable, and then passes it to the difficulty level method as a parameter. Additionally, it ensures that the same LED cannot blink twice or more in the row. We've accomplished this by using for loop, which goes through the generated array and compares 2 values stored next to each other. The section main game starts off with a while loop, which controls the number of rounds each game is going to last for. It contains the majority of the code responsible for progressing through the game. The rounds variable is being compared to count variable, which always start at 1, and then gets incremented with each passing round. When count value, after number of incrementations, exceeds the value of rounds, the loop will no longer be executed. The loop begins with invoking this method, which takes the values stored in the previously generated int sequence and then executes LED flashing method. What's vitally important, this method is controlled by for loop, and the number of times LED flashing method is executed depends on the variable count, and the very same variable used by us to control the while loop. This means that with each passing round, the program will execute 1 time more than the previous round. In the very first round, only 1 LED will flash, while in the second round, these numbers will increase by 1, 2 flashes and 2 sounds, and so on. The LED flashing method basically tells the user which buttons need to be pressed in order to progress through the game. The input from the user is received through the keypad and is being stored in the int answers array, which is exactly what populate int array does. It works similar to populate int sequence method, as it also uses the for loop controlled by count variable. The main difference is it takes the input from the user instead of using generated numbers. Because the keypad uses ASCII character set, we've used the switch statement to translate them into 1 to 4 numbers and populate the array with those numbers. If the user has pressed the right colored button, hinted by the LED blink and the sound made by the buzzer, then the validation ends there and the for loop can start over. If, however, the pressed button was incorrect, the Boolean value of the if statement is false, and the next 2 methods contained within the if statement will be invoked. The first statement, losing animation, will make the LEDs blink in a certain sequence, indicating that the game is lost, while the next one, reset function, will make the program restart itself and start the execution from the beginning. The losing animation is slightly different from the previous ones, as it uses pulse width modulation to make the LEDs fade in and out. The animation will run twice, which is controlled by the for loop, while the while loop is responsible for the dimming effect itself. The starting value of J variable controls while loop, and the brightness of the LEDs is set to 0, and it will increase by +15 with every passing loop, shining for 30 milliseconds each time, which is enough to make the dimming visible. Once the value of J exceeds 255, while J is less than 255, the loop terminates and another while loop begins. The very last method in the for loop, reset function, simply sets the count value to its initial value, 1, and starts the loop method again. Thank you for watching. We hope you've enjoyed this video as much as we enjoyed creating this project. For more detailed explanation, please refer to our written documentation.